All right, this is my Calculus 1 related rates video in my related rates lab number 2, and it's about a train and a plane. So I have a train that's heading due west from Watertown. So I'm going to draw my little picture here, due west from Watertown. At noon, a plane flying horizontally due north. So here's my plane, here's my train. At a fixed altitude of 4 miles, so that is 4 miles above the earth. We'll talk about that in a minute. Passes directly over the train right here at noon. So they're passing over each other. So the plane's going north, the train's going west. When the train has traveled another mile, so I'm going to call this X, and that's going to be 1 mile, is going 80 miles per hour. So dx dt would be 80 miles per hour. I know you can do mph. Okay. The plane has traveled another 5 miles, so we're going to call this y, and that's going to be 5 miles. Okay. And it's going 500 miles per hour. So that's my dy dt. Okay. So this is a right angle. I'm just going to draw this line here dotted for a minute. I'll tell you why in a minute. At what moment, how fast is the distance between the train and the plane increasing? Well, on our normal time when we were doing this, we would look, oh, we're looking for this side right here. This right here is, if I were looking at this flat. So what I said to everybody in class is pretend I'm God and I'm looking straight down above this. The plane is going north, so here's north. The train is going west, and when I look at it, it looks flat. But in all actuality, this plane is up 4 miles from the earth. Okay, so if I'm looking down, or like I was telling class, when we got tickets to go to see Yankee Stadium, a game at Yankee Stadium, we were up so high that when they did a high pitch, it looked flat to us because we're looking down. When actuality, this is not flat. There's a third dimension. So I'm going to be now the person standing on the ground, and I'm going to be looking at this. So here is the plane, and it's kind of going in that direction, which is north, and they're 4 miles above the earth. Okay. So what you're looking at, and the train is going this way, is you're kind of looking at, as this train is moving and the plane is going north. Okay. So I'm looking at this straight on the ground. Okay. There, this is 4 miles from the earth. So the plane is above me. So what you're looking for is really this, which is Z. You're looking for this ever-changing third dimensional shape. It's not flat like it would be over here for S. So I'm not really looking for S. What I'm looking for is Z, from where this train is going all the way up to the plane going into the board or into the paper, if you will. You're looking for Z. So that's our third dimension. So we're looking for basically dZdt because they want to know how fast is the difference changing. Okay, so because of this, when we have a third dimension, when we go to find what formula we use to figure out what z is at the moment, this is 1 mile and the other is 4 miles, is you're going to use this. Z squared equals x squared plus y squared plus 4 squared. There's my third dimension right here, the 4. So I look at this and I'm going to plug in everything I have. I have z squared equals 1 squared plus y squared is 5 squared plus 16. So z squared, well, I can just, you're going to add that all up. And when you do that, you're going to get 42. So z squared equals 42. And when I take square root of both sides, z is radical 42 miles. Okay? That you need to have. All right? So now I'm going to go through and actually do the derivative. So I've kind of used a lot of space here. So we're going to use this formula is what we're going to take the derivative of, because I have z's moving, x is moving, and y is moving, but this is my constant of 4. So you're going to do 2z dz dt plus equals, sorry, I keep saying plus, equals 2x dx dt plus 2y dy dt. And when I take the derivative of 4 squared or 16, it's 0. So that's, let's try that again, 2y dy dt. So this third dimension helps with finding this radical 42, but when I take the derivative of a constant, it's 0, so it kind of disappears. Now I'm going to get rid of all the 2's. Thanks for playing. So now I have z dz dt equals x dx dt plus y dy dt. And then we're just going to plug in everything we know. So z is radical 42. I'm looking for dz dt equals x, which we know is 1 mile, times dx dt, which is 80, plus y, which we know is 5 miles, times 500. And when I go through and do that 1 times 80 and the 5 times 500, and then divide it by radical 42, you get, I'm kind of down on this one here, but dz dt comes out to be 398.1 miles per hour. That's how much that this third dimension right here is changing as the plane is still continuing to go and the train still continue to go west and the plane is going north. So I hope that helps you.